Okay, so let's consider this problem where there is gravitational field and also it requires some knowledge of eigenvectors. So two particles move in a uniform gravitational field with an acceleration g. At the initial moment, the particles were located at one point, basically at the same point, and moved with velocities. These are the magnitudes v1, v2, horizontally in opposite directions. Find the distance between the particles at the moment. So we need to find the distance. The particles at the moment when their velocity vectors became mutually perpendicular. Okay. So first of all, let us find the time at which the particles' velocities became mutually perpendicular, and then we can find the distance later on. So let's draw the problem situation. So let's say the point of origin, I mean the initial starting point, the two particles, and one so they are basically moving horizontally in opposite directions initially. Fine. Let's say one particle moves in this direction, the magnitude of v1, and then moves in this direction with the magnitude of v2. Let's say that g is downwards, g. Okay, and let's say this is the positive x direction and this is the positive y direction, right? So now so obviously because of g, what will happen is the particles will have some sort of because of the gravitation it will have some sort of a parabolic trajectory, both the particles. One particle will go this way, the particle will go this way, and somewhere some instant of time the velocity directions, they will be basically sorry for that, velocity directions will be perpendicular to each other. So we need to find out the time first and then the distance, let's call it d, at that instant. Okay, so let's find out the general, like at any point, at any time instant t, let's see what their velocities would be. So in general the horizontal velocities won't change because there is no horizontal acceleration. Since there is vertical acceleration, this will be the vertical velocity will change with time. Okay, so let's consider particle 1. So particle 1, the v1x, so for particle 1 it's in the positive x direction, so it is a constant v1, and v1y is equal to, so the initial velocity in the vertical direction is 0 because it's only given on or like it only has a horizontal velocity. So v equal to u plus at, so u is 0 and a is basically g is positive in the downward direction. So basically the acceleration is plus g because y axis is in the downward direction, g is also in the downward direction. 0 plus g times t. T is the time, so gt, right? Similarly, for particle 2, we have v2x equal to, now this is important, the direction is important here. So the initial velocity is of the the horizontal velocity is in a direction opposite to that of the positive x-axis. So v2x is essentially minus v2, and v2y is again similar to v1y, which is 0 plus gt, which is again gt. Okay, now if we have to find out whether when the velocities will be perpendicular to each other, so we need to write it in terms of vectors. So let's call it, so just for so that there is no issue with the notations, we'll change 1 to particle A and particle 2 to particle B. So this will just become VAX, VAY, VBX and VBY, so that there is no confusion between notations. So I'll just write VA vector, right? So in general we represent it in terms of like I cap, j cap. The x-axis direction is represented by I cap and the y-axis is represented by j cap. So VA in that case would be V1 I cap plus GT j cap. Similarly VB be minus V2 I cap plus GT j cap. Okay, so let's say at some t naught VA is perpendicular to VB. This is at any instant t, these questions. So this means at that instant VA dot VB, the dot product, equal to 0 at t equal to t naught. So what is the dot product? It's essentially the sum of the products of the individual components. So we'll multiply the x component first by minus v1 v2, and we'll multiply the y component and we'll add. So gt whole square to 0, right? Now gt will be square root of v1 v2. So in that case t become root over v1 v2 by g. So this is the time. I should call it t naught, that's better, right? So you got the t naught at which the velocities are perpendicular to each other. Now we need to get this distance d, right? So let's see. So the distance would be so since d is okay, so here is one thing which is very interesting to note, that no, this is a like really important point. I'll just use now since both particles have zero initial velocity in the y direction, displacement in the y direction is same for both. So if I just write it as sy in both cases, using ut plus half at square, since u is 0 and a is g, will be half gt square for both particles. So at any given time, they are essentially in the y-axis, they have zero distance. I mean, they're the same height. So you only need to find out what is the horizontal distance between them, right? And in the horizontal direction, they just have constant velocities, so it's very simple to calculate. So what would be the distance? Let's see. Since both the, I mean, since it's a constant velocity thing, the first particle will travel after a point of time, after time t, the first particle will travel a distance of v1t in positive x direction, and particle 2 will travel a distance of v2t in the opposite direction. So essentially d v1t plus v2t is nothing but like v1 plus v2 into t. Now we already know, we already found out, let's call it t naught because it's after t naught. So we have already found out that t naught is root over v1 v2 by g, v1 v2 by g. So this is the distance. So distance is equal to v1 plus v2 into root over square root of v1 v2 divided by g. So here you can substitute the values of v1 v2 and g in order to get the distance. So that's that. Thank you.